Hello students, in this video I am going to discuss on a topic quantum numbers. Now before we jump to quantum numbers, let us first discuss about Bohrs model. Now all of you know that how was the Bohrs model look like, that in the center there was a nucleus and around nucleus electrons revolve in well-defined orbits, and these are the orbits or they are the energy shells. Now these energy shells, they could be represented by symbol n. It could be 1, 2, 3, any positive integer, or they can be represented by k, l, m. So these orbits, if electron is here, then it will have a fixed energy. And if it has to move to this one, it required that much energy. So these orbits were like ladders, that each ladder has a fixed level or step there. So we say that these orbits, they are quantized. One definite energy is there कि ऐसे नहीं कि continuously कोई भी energy वो assume कर ले. एक fixed energy है, fixed value है उसकी. So that for that we use the term quantized. So these were the circular paths in which the electrons revolved. But later on, in few experiments were conducted. One was de Broglie equation. In de Broglie equation, that any particle, if it is in motion, it has mass and wavelength. So this was like it has a wave nature as well as it has a particle nature. Or we say that matter has dual nature. It can behave as particle, it can behave as wave also. So for this equation was given. Lambda wavelength, m is the mass of electron, v is the velocity, and h is one constant is given, that is Planck's constant is there. So if we follow this equation, then according to this, then like in Bohr, he said that in electron move in definite path. It is on this line. But according to this, electron cannot move in definite path. It will move like this. That is, it is like a wave-like character. It should move like a wave. So that is here the Bohrs model could not explain this. Then another principle was Heisenberg's uncertainty principle. So according to this, that we can measure either position accurately or we can measure momentum of the particle accurately. Both the things we cannot measure simultaneously, so some error could be there. So he gave this equation, that is delta x. If we are measuring the position of electron, तो exact position में कुछ variation रहेगी, वो variation कितनी होगी, that is delta x is there. Similarly, some variation could be there in the velocity, so that is change in momentum. Momentum, you know that it is equal to mass into velocity. So mass of the product cannot be changed, only the value. Velocity can be changed. So there could be uncertainty in this one. So this was Heisenberg's uncertainty principle. So these two principles could not be explained on the basis of the Bohrs model. So then comes the another model, that is called the quantum mechanical model. Now it treated electron as wave. So it also forms the basis of wave mechanics. Like Newton's law or some, they form the classic mechanics. And of course, daily life, whatever things we come across, they become same. Because a wave-like character we cannot see in daily life. We come across macroscopic objects, table we can see, book it is there, so we can't see the wave character in it. That is only applicable for microscopy. Now in this, there is this name, very Harry Barkham name, that is Schrödinger. he gave, this is a mathematical impact model is there. So it describes the electron, position of electrons in atom, that is based on the Schrodinger equation is there. So we won't go in detail much about that Schrodinger equation, but yes, it treated electron as wave, and he gave a mathematical equation to find the position of electron in an atom. So for finding the position of electron, like in Bohrs model, we required only value of n. If n is equal to 1, it means it is present in first shell. If it is 2, it is present in second shell. But since it is moving in a wave form, so that we require some variables there. So in quantum mechanical model, it considered both the rules, that Heisenberg uncertainty principle and also the de Broglie equation. It considered both these in this, and it treated electron as wave, and the electron is found in three-dimensional space that is called orbital. Yeah? So it is a three-dimensional space, and here electron, the probability, it is the area where probability of finding electron is maximum. Right? So in Bohrs, we had discussed about orbit. It is a two-dimensional, like circular, but it is a three-dimensional there. So here you can't say that well defined. It is the region where probability of finding the electron is maximum. So the four variables that we need are n, l, m, and ml and ms. So these four quantum numbers we will discuss one by one. Like n, it is the Cardiff principal quantum number. So here just see the spelling of principal, same we are using for the application to the principal. Now these quantum numbers, so these are set of numbers that specify position of electron in an atom. Atom कह सकते हो, orbital कह सकते हो, that would be. So principal quantum number, it is the head. So it represents the main energy shell, and it can have values 1, 2, 3. That is, it take up the values of positive integers. It cannot be 0. Or as you know, it can A, L, M. Now, what does it signify? It represents the size of atom. If value of n is 1, very small. If it is 2, size increases. If atom has a 3 shells, then again the size increases. So as the number of shells increase, the value of n increase, the size of atom increases. Similarly, energy of atom also increases. As the value of n increases, it moves away from the nucleus, then energy of shell also will increase. Then n square. This n square will give the number of orbitals in atom, or in given shell, that is we say, and in given shell, say. And 2n square, if you remember, that it gives the number of electrons in given shell. Right? If I say n is equal to 1, the number of orbitals, n square means 1, and number of electrons, it will be 2n square, 1 square, so 2. Similarly, another value if we take n2, then orbitals 2 per square, it will be 4 orbitals, and electrons 2n square is there, so number of electrons in second shell will be 8. So from main energy shell we can find this. So here then another second quantum number is L,